There is a bridge in China where drivers roll down their windows for a completely different reason than usual. Not for fresh air. To make their ears pop. Because 625 meters beneath their tires is a river that, from that height, doesn't even look like it's moving. Let that sink in for a second. 625 meters. If you stacked the Empire State Building on top of itself and then added 600 feet more, you still wouldn't touch this road. And this isn't some abandoned test track built for a headline. Cars drive across it. Trucks drive across it. Tour buses full of grandparents taking photos drive across it. Every single day. So here's the first question worth asking, and it's not the one you'd expect. It's not, how did they build this? It's, why would anyone need to? Because the answer to that question opens the door to something much bigger than one bridge, a shift in how an entire country builds things. One that's already spreading far beyond its own borders, and most people watching construction videos online have no idea it's happening. Would you have believed this was possible 10 years ago? Be honest. Because in September 2025, this bridge didn't just open quietly. It opened and immediately became the highest bridge on the planet, not by a narrow margin, not by beating the old record by a few careful meters, but by smashing past it by more than 200 meters. That's not breaking a record. That's a different category entirely. Now here's where things get strange. This story doesn't start with steel or concrete. It starts with a problem that had nothing to do with engineering at all, a problem of isolation. For generations, villages sitting on opposite sides of this canyon in Guizhou province could see each other. Close enough to wave. Close enough to hear a rooster crow from the other side. But to actually visit? That meant a 2-hour drive down one side of a cliff, across a valley floor, and back up switchback roads on the other side. Neighbors who could practically shout hello to each other lived, in every practical sense, 2 hours apart. Here's the part that should genuinely stop you. That 2-hour trip isn't down to 1 hour now. It isn't down to 30 minutes. It's 2 minutes. Barely enough time to finish one song on the radio, and you're already on the other side of a canyon that used to swallow an entire morning. But before any of that speed was possible, engineers had to answer a question that sounds almost like a trick. How do you build a bridge when there is nowhere on Earth to stand while you build it? Think about what a normal construction site actually needs. Solid ground. Scaffolding resting on that ground. Trucks rolling materials in and out. None of that exists here. On one side, sheer rock dropping straight down. On the other side, the exact same thing. In between, 600 meters of open air and a river reduced to a silver thread by the distance. Every single component of this bridge had to be assembled while hanging in space, piece by piece. From cables anchored into cliff walls that themselves weren't trustworthy enough to build on without help first. Would you trust a mountain to hold up a highway? Because the engineers didn't, not without proof. Before a single support tower rose, crews drilled deep into the canyon walls and locked unstable rock layers together with steel anchors. Essentially rebuilding the mountain's skeleton from the inside. It's the part of the project that almost never makes it into a highlight reel. And it's also the part that determines whether everything built afterward survives. Once the cliffs themselves became trustworthy, 2 towers began climbing straight out of solid rock. One reaches 262 meters. The other reaches 205 meters. That's taller than most skyscrapers you've ever walked past, except these towers aren't rising from a city block with streets and sidewalks around them. They're rising from a knife edge of stone, with nothing below but open canyon air. This is usually the part of a construction story that gets compressed into a quick time-lapse. Towers go up, months blur together, done. But this stage is actually where the entire project could have unraveled. Wind behaves differently at 200 meters than it does at ground level. A crane operator working at that height isn't just fighting gravity, they're fighting invisible gusts capable of shoving tons of suspended steel sideways in an instant. Every lift, every weld, every single bolt placed up there demanded a level of precision a ground floor building never has to think about. Now here's the twist almost nobody expects. Once both towers were finished, the hardest part of the entire bridge hadn't even begun yet. Because now came the gap. The actual, physical, terrifying empty space between two cliffs that somehow had to become one continuous structure. Engineers started small, pilot cables barely thicker than rope, fired across the canyon first. Stronger cables followed, anchored to the tops of both towers and pulled taut. For the first time in the entire project, something physically connected both sides of the canyon. But it was still just a skeleton. A framework hanging in space. The actual roadway, the part vehicles would eventually drive across, didn't exist yet. Piece by piece, the real deck began closing that gap, hanging from the cables above like beads threaded onto a wire. And the closer both sides crept toward each other, the more dangerous the work became. Why? Because a structure suspended in open air never sits perfectly still. It sways in the wind. It shifts as the temperature changes throughout the day. Engineers had to align two moving targets, both hanging hundreds of meters above a river, and bring them together within millimeters of each other. Take a second and actually sit with that number. Millimeters. At that height. In open wind, above a drop that would make most people's knees buckle just looking at a photo. If this were a disaster movie, this is the scene where everything goes catastrophically wrong. In real life, engineers spent months controlling for exactly that possibility. Using satellite-based positioning systems accurate enough to track the bridge's movement in real time. Constantly adjusting tension so that when the final segment finally lifted into place, both halves fused into one. That single moment, when two separate pieces of steel, built from opposite sides of a canyon, finally touched hundreds of meters above the water, is the moment this stopped being two construction projects and became one bridge. But even then, it still wasn't ready for a single car to cross it. Because now the bridge needed a surface people could actually trust their lives to. Asphalt laid and compacted at altitude, in wind that never fully stops. Guardrails installed along a drop most people wouldn't even lean over to photograph. Expansion joints built directly into the structure, because steel this long doesn't stay perfectly still, it breathes. Expanding and contracting as the seasons change, and the bridge has to be built to move with it instead of fighting it. And then, before a single ordinary vehicle was allowed on, came the test that decides absolutely everything. Engineers loaded the bridge with dozens of heavy trucks, nearly 100 of them. A combined weight north of 3,000 tons, and drove them onto the span all at once. Sensors buried deep inside the structure tracked every millimeter of movement, every fraction of stress, feeding the data back in real time. If the bridge behaved exactly as the models predicted under that kind of weight, it would be cleared for the public. If it didn't, none of the previous 4 years would matter at all. It passed. On September 28, 2025, the Huajiang Grand Canyon Bridge officially opened, instantly becoming the highest bridge on Earth at 625 meters above the river. To put that number in perspective, America's highest bridge, the Royal Gorge Bridge in Colorado, sits 956 feet above its river. This one sits over 2,000 feet above its river. More than double the height, on a completely different continent, built for an entirely different reason. But here's what most people watching from outside China completely miss. This bridge wasn't just built to move traffic. It was designed, on purpose, to pull people toward it. There's a glass-walled cafe built directly into one of the towers, roughly 800 meters above the valley floor. Reachable only by a high-speed glass elevator that runs up through the structure itself. There's a skywalk nearly 1,900 feet above the canyon floor, made almost entirely of glass. There's bungee jumping directly off the bridge structure. Within weeks of opening, extreme sports athletes from multiple countries were already competing on it. Now here's the detail that should really make you pause. This bridge isn't an isolated stunt sitting alone in the mountains. Guizhou province had fewer than 3,000 bridges back in the 1980s. Today, it has more than 32,000. 3 of the 7 highest bridges on the entire planet sit inside this single province. If this becomes the norm rather than the exception, what happens to how the rest of the world defines impossible terrain? But wait, because bridges are only half of this story. The other half might honestly be even harder to believe, and it has nothing to do with canyons, cliffs, or rivers at all. It's about how fast an entire building can now come together, and it's not happening in some experimental lab hidden from view. It's happening in real cities, for real buyers, right now, while most of the construction industry elsewhere is still pouring foundations the old way. Imagine a construction crew showing up to a completely empty lot on a Monday morning. By Friday afternoon, a 26-story residential tower is standing there, fully assembled, water and electricity connected, ready to move into. This isn't an exaggeration added for dramatic effect. A company called Broad Sustainable Building actually did exactly this. Assembling a 26-story tower in 5 days using modules manufactured almost entirely inside a factory. Then trucked to the site and stacked together like enormous steel building blocks. Would you have believed that 10 years ago? Because most traditional apartment towers take a year or more just to reach street level, let alone become move-in ready. This approach flips the entire process on its head. Instead of building upward slowly on an exposed site, fighting weather delays, material shortages, and scheduling chaos, almost the entire structure gets manufactured indoors, under controlled factory conditions, and only gets assembled outside once it's already essentially finished. And this approach has stopped being a purely domestic story. In December 2025, the same company completed a 16-story residential tower in Abu Dhabi called Earth Tower, 259 individual modules. Manufactured in just 30 days, then lifted into place and bolted together on-site in 96 hours. 4 days. For the structural assembly of an entire 16-story building. No concrete involved anywhere in the system, the entire tower uses bolted stainless steel modules instead. Which also means dramatically less construction waste, less noise, and less dust choking the surrounding neighborhood for months on end. Here's where it gets genuinely strange. The developers behind that Abu Dhabi tower are already planning future buildings between 15 and 30 stories tall. With total construction timelines under 6 months, at costs comparable to conventional building methods. Now here's the question almost nobody is asking out loud. If a 30-story tower can go up in under 6 months, at a price similar to a traditional building, what exactly is traditional construction still offering that this doesn't? Most people miss what this actually means for the rest of the world. This isn't a one-off gimmick built for a press release. The global market for this kind of factory-built, modular construction was worth over $170 billion in 2025. And it's projected to nearly double within the next decade. China isn't just participating in that growth, it's the fastest expanding market on the planet for it, growing faster than anywhere else on Earth. Faster than Europe, faster than North America, faster than the countries that supposedly invented modern construction in the first place. And here's a detail that rarely makes it into any of these stories. None of this actually started as a race for headlines. Long before Earth Tower went up in Abu Dhabi, the same company had already been experimenting with entire prefabricated towns back in China. Refining factory-built systems for over a decade. Quietly turning what used to look like a novelty into an industrial process reliable enough to export overseas. What looks like an overnight miracle is actually the visible tip of 10 years of unglamorous factory work that most of the world simply never saw. So here's the bigger picture forming across 2 completely different projects, a highway floating 600 meters above a river. And an apartment tower assembled like furniture, just at a scale nobody thought was possible outside of a warehouse. On the surface, these look like unrelated achievements. One is about crossing terrain everyone else would avoid. The other is about building faster than anyone thought buildings could go up. But underneath both of them sits the exact same idea. Stop treating "too difficult" as a reason to wait, and start treating it as an engineering problem with a deadline attached. If this becomes the standard instead of the exception, what happens to construction everywhere else? What happens to cities that still take a decade to plan, approve, and finally finish a single high-rise? While somewhere else on the planet an equivalent building goes up before the concrete on a traditional foundation has even finished curing? What happens to remote regions written off for generations as too difficult to connect? In a world where a single province went from under 3,000 bridges to over 32,000? Here's the honestly uncomfortable part. None of this is secret. None of it is classified or hidden behind a wall of corporate silence. The bridge is open to tourists right now, today, with a coffee shop suspended above the clouds. The modular towers are getting covered in trade publications almost nobody outside the construction industry ever reads. This isn't happening in the shadows. It's happening in plain sight, at a speed and scale that simply doesn't match how most of the world still pictures a construction site working. So here's the real question worth sitting with after this ends. Somewhere right now, another impossible canyon is being measured by engineers with drones and satellite equipment. Somewhere else, another empty lot is being cleared for a tower that might rise in days instead of years. The real question was never whether this kind of building keeps spreading. The real question is whether the rest of the world catches up to it in time, or gets used to watching it happen from 2,000 feet below.